Unit 3, page 3 test. All right, so this is cube root. So we're looking to take out groups of 3 because, like, if it was 8, 3 2's multiplied to be 8, so the cube root of 8 is 2. Well, what do we have for 54? Well, that's 2 times 27, and 27 is 3 times 9, which is 3 times 3 times 3. So that's 54. The negative, well, that could be negative 1 times this, but negative 1 is also negative 1 times negative 1 times negative 1. So the cube root of a negative, in fact, the odd root of any negative, the negative just comes outside. So the negative pulls out. The 3 3's will come out as a single 3. And it says there's x 4 times. 3 of them will come out as an x, and we don't have to worry about absolute value on odd roots, so don't even need to think about it. And there's a single y there, so I've taken out everything except the 2 and the x and the y. Those are still in the cube root. That's the first one. Second one. So this is square root. So now I have to worry about odd number of x's coming out and make sure that they stay positive. So I have a 5 already out. 18 is 2 times 9, which is 2 times 3 times 3. And x, taking out 2's, pairs. So there's a pair of 3 comes out and multiplies times the 5. So that makes 15. Now I got the 3's out. A pair of x's will come out as a single x. And a single x, a negative would be negative. So we got to put an absolute value on it because there's no negatives coming out of a square root. That takes those out and it leaves a 2x inside the square root. Now, this all looks exactly like this. So it's kind of like saying we got 15 of these bananas minus 2 of these bananas. And so we end up with 15 minus 2, 13 of these absolute value of x, square root of 2x. That's the answer to that one. Now this one can be done a couple of ways. Since there's no addition in here, we can distribute the power. Now 16 is 2 times 2 times 2, 2 to the 4th. X squared y to the 1. And we can take the 3 halves times each of these. 4 times 3 halves would be 12 halves, or 6. 2 times 3 halves is 3. And 1 times 3 halves is 3 halves. Now, beware here. The numerator is saying this happens 3 times. The denominator tells you the root. So this is the square root. And if I'm going to take out an odd number of x's out of a square root, it has to be absolute value. And in fact, this y to the 3 halves is the same as y to the 1 and 1 half. So that's the same as y to the 1 times y to the 1 half. And y to the 1 is an odd power on it, so I'd have to do absolute value. And this would be the square root of y. So this would come out to be 2 to the 6, which is 64. Absolute value of x to the 3rd. Absolute value of y because of the 1. And then we'd still have the square root of y, or y to the 1 half. Now let's do it the other way. The numerator says 3 of these. It's cubed. 3 of them multiplied. So this is 2, 2, 2, 2, 16. x, x, y 3 times. And we're taking the square root of that. So we're looking for pairs. 1 pair of 2's is a 2, 2 pair, 3 pair, 4 pair, 5 pair, 6 pair. I get 2 to the 6, which I've already said is 64. 1 pair of x's, 2 pair of x's, 3 pair of x's, that's x to the third. That's an odd number coming out of an even root, so we have to do absolute value. And we have 1 pair of y's right here. That comes out as a single y, absolute value, and there's 1 left under the square root. And that matches the other answer that we had right here. 64, absolute value of x cubed, absolute value of y, square root of y. All right, bottom of this page. What's the common factor in all of these bases? So let's see, that's 2 to the 4th, that's 2 to the 3rd, and that's 2 squared. This 2 to the 4th is in the denominator, so I should think of it as 2 to the negative 4. The negative puts it in the denominator, and the 4 makes it 16. And then I have 2 to the 3rd to the 3x plus 2 equals 2 squared, which is 4, to the 2x minus 3. Now, if we have a power to a power, we have to do those before we do any of these combining of products here. A power to power, so I multiply the power. So I have 2 to the minus 4 stays, 2 to the 9x plus 6 equals 2 to the 4x minus 6. Okay? Now, when you're multiplying, you add the powers. Power to power, you multiply, but when you're multiplying, you add powers. Some people tried to multiply here. It's add the powers. So we get 2 to the 9x plus 6 minus 4 is 9x plus 2 equals 2 to the 4x minus 6. Now the bases, we're down to a single equal base, so the powers must equal. So I can write 9x plus 2 equals 4x minus 6. Subtract 4x from both sides. 5x plus 2 equals negative 6. Subtract 2 from both sides. 5x equals negative 8. Divide by 5 on both sides. And x equals negative 8 fifths. And I can put that in for the x's on this side and for the x's on this side. Figure out what that is on the calculator. Figure what the other side is in the calculator. And they should come out to be equal answers. Same way I would test this one. All right, 27, 9, and 3. That's all powers of 3. 27 is 3 cubed to the x. So we're going to multiply here because it's a power to a power. 9 is 3 squared. And then we have 3 to the x plus 5. Here we're multiplying, so we add the powers. So here we get 3 to the 3x equals 3 to the, we're adding. So it's not 2 times this, it's 2 plus x plus 5, which is x plus 7. Bases are the same, so 3x must equal x plus 7. Subtract x. 2x equals 7. X equals 7 halves, or 3 1/2.